Hi, welcome back to the discussion series on how to generate test cases from a given regular expression. I'm going to show you some regular expressions that are already published online to detect a MAC address is valid or not, and we'll use the SMT solver and Rex syntax solver to generate an automaton from a regular expression and essentially fix the bug that we talked about in the previous segment of this series. Okay, so here is the valid MAC function that we have been using since the previous session. The problem is that this valid MAC function is actually not exactly matching valid MAC addresses. They actually, it matches pretty much any arbitrary string, more or less, that you provide. So that's basically the problem. And as you can see here, I have been sending 12 A's, and 12 A's perfectly match this expression because it's matching 2 times right here. That means AA is 1 group, another AA is 2 group, 3 group, 4 group, 5 group, and 6 groups. That's exactly what this regular expression is asking for, right? What we can do is basically copy and paste this and look at the automaton. In the previous segment, I did that, but I'm going to do some small change. So what I'm going to do is just go back to the Rex syntax, Rex tool, and look at the automaton that comes out. Okay, so it's a long one. So what I'm going to do is assume for a moment that we only have to accept 3 groups. Okay, the automaton will be small for us to visualize. Okay, so here it is, right? Much smaller. So we accept. By the way, this means the empty transition. We call it Epsilon transition in theory of computation. We basically start at state number 13, and we accept any arbitrary characters, right? That's why there is a loop, and that's very important to note because we can put anything in the front. When I did this testing earlier, I was just copying and pasting the valid address here, right? And let me show you this. And if you can put AAA, this is going to work because it matches the regular expression. It says it's valid, but from an automata point of view, you can imagine that what's happening here is that you're starting at state 13, right? And skipping 1 state at a time until you reach the end of the state machine. Okay, what does it mean by end of the state machine? The accepting state. Okay, so let me show you the accepting state. I have to zoom in a little bit more. Okay, maybe I should even do some other trick now. Let me change the size further down just to get the automaton on a complete screen. Okay, I think I'm getting there. So here it is. So you see here, it matches the first character A, second A. Of course, the colon that you're probably seeing it in small dot is here. That's optional. That's why there is a fork. And then empty transition is perfectly fine. So it accepts A, first character, second character, a third character, and fourth character. So this one is only accepting 2 groups of 4 characters. So you can imagine if I just change this to 3, 4, 5, it will be a large state machine. But this is basically the idea behind this matching, right? So given this background on how to map from one state to another state or one regular expression to automaton, let's go back to some published materials online about MAC. Okay, one place is MAC address discussion in Wikipedia. May not be the best place all the time, but oftentimes I find Wikipedia interesting and nice. So I'm going to just select a few things that are important for us. So what they're saying here is that there is something called EUI48 address format, human-friendly format. You can separate it by minus hyphens or by even in some cases colon, as you can see. So there are 2 options. So let's consider the option of using a colon, and you have also to consider 2 scenarios. Okay, one is called EUI48. Another is EUI64. So I'm going to only show you now the EUI48 format, right? Which means that there are 6 groups, right? 1, 2, 3, 4, 5, and 6 groups. Okay, so let's take a regular expression, which you can find it online from regex library, for example. But you have to be careful. Not all regular expressions are meaningful and valid in all cases. But let's take this one and see how the automaton looks like. Okay, so we can go here and put it here and look at the automaton. Okay, so this is much bigger, so I'm going to reduce the size significantly. Let's see. So this is much easier to see. We are at the starting state 0. We accept what are we accepting? We accept any character, and then another character, and then we must have a colon. Colon is not an option anymore. We must have a colon, and then another character, and again must have a colon, character, and then we're ending. Okay, that's perfectly fine. This looks like the correct automaton we need. So let me revert it to the scenario that was modeled. I think it was first 5 blocks must have the colon part, right? And then the rest is not colon part. That's why it's repeated separately. So let's run it. Okay, now we have the perfect automaton built for this expression. And one more important thing is to notice that it starts with a cap and end with a dollar to make sure that you are not matching against a substring. Okay, so let me show you some. You can see the difference if I ignore this, right? So now you see weird things, right? State number 22 has a loop. That means you can have any number of characters at the front. The system will stay at the same state, right? And then it starts transitioning to the rest. Okay, that's one possibility. It's kind of a loop here. That's what the reason why we wanted to put something like this. So we don't have a matching matching a substring. Okay, so now the automaton is much clearer, and now we will be able to generate test cases from this. So we have very nice collection of test cases, okay, automatically generated for us. We can now go to here and plug in one of the test cases. Okay, so of course my regular expression has to be changed, so I have to make use of the same regular expression we got from the internet. So I'm going to copy this and put it here as part of the pattern matching. Okay, as you can see, the original one didn't have the cap symbol and the dollar symbol. That's the reason why it was matching substrings as well. Now we are very strict. Okay, so now execute, should be valid, perfect. Let's put some AA in the front and convince ourselves this is not going to be accepted. This will not be accepted. Okay, it's invalid, perfect. So the point I wanted to get across today is that when you validate against a regular expression, it's a tricky business. Getting the regular expression correct is challenging. You wanted to visualize your automaton. Converting a regular expression into automaton is automatically carried out by Rex-like tools that use symbolic analysis ideas like SMT solvers under the hood, which we have done a lot of discussions on that. Okay, so that's one point. Another point is that you may also want to be careful about the input length. Here, there's no input length, right? If this input is coming from the user, maybe we can put a limit. Okay, if before even we evaluate the regular expression, we can say if I'm not a PHP programmer, so I'm going to write only algorithm. If MAC address length is not equal to 48, then you say error. Okay, return error. Okay, something like that. Okay, this is basically the idea behind verifying in a more structured way. First, verify the length, and if the length is not good, you already reject him. Otherwise, we go to the next stage. Okay, so the main point is conveyed, hopefully, that testing the regular expression is a tricky one, and we can generate it using PEX-like tool or Rex-like tools, actually. Okay, that's basically what I wanted to share. Thank you very much.